I want to talk about one of my favorite topics on the GRE math section, trailing zeros. In this particular question, we're going to deal with big factorials. It's a thing they're doing to try to make you to do more work in this QC question. But what I'm going to show you here is how you can get through this question quickly, simply, without a ton of work. So let's check it out. As mentioned, this is one of my favorite quant topics, dealing with trailing zeros. Now, what we're given here in quantity A is we're being asked the number of zeros, trailing zeros in 200 factorial, and then secondarily in quantity B, the number of trailing zeros in 204 factorial. Now, if you've been in the TTP course, we have a very cool shortcut with factorial divisibility and how to figure out the number of trailing zeros in 200 factorial and 204 factorial. But here's the catch. Do we want to go through all that work here? Well, I certainly don't, because it's going to take time and effort, and I'd rather save that time on a harder question. So here's the deal. What do we know about trailing zeros? To get a trailing zero, it's about the number of 5 and 2 pairs in the prime factorization of the number we're dealing with, right? Well, guess what? The number of 5 and 2 pairs is not going to be any different in 200 factorial versus 204 factorial. And the way we know this is simple. Remember, when we're dealing with these pairs and analyzing any factorial like this, from the outset, we know there's going to be more 5s than 2s in a factorial like 200. And the reason is there are obviously less 5s in 200 factorial than there are 2s. So we're really just focused on the number of 5s here. So can we say that 200 factorial and 204 factorial have the same number of 5s? We can, because the only difference between 200 factorial and 204 factorial is this. It's 204 factorial is actually equal to 200 factorial times 201 times 202 times 203, and we're a little bit out of room, so we'll put it down here, times 204. Now, is there a 5 in 201? No. Is there a 5 in the prime factorization of 202? No. How about 203? No. How about 204? No. So what we've determined is the number of 5s, and thus the number of 5-2 pairs in 200 factorial, is equal to the number of 5s or 5-2 pairs in 204 factorial. Therefore, the number of trailing zeros in 200 factorial is equal to the number of zeros in 204 factorial, thus making the answer C. The two quantities are equal.